Welcome back, guys. So in this video, we'll see what resolution is. We'll understand the term resolver, and then we'll be discussing the types of resolution. So let's start right away. All right, guys. So we're beginning with resolution, right? We're starting with resolution. Okay. So by resolution, we mean resolving a query. Resolving a query. Okay, so query can be of two types. Either we can be looking like we have the IP address and we are looking for the name, or we have the name and we are looking for the IP address, right? So it can be either address to name or name to address. Okay, so when we perform either of these mapping, it's known as resolution. Okay, like we are resolving a query, right? We are just simply solving a query, so it's called resolution. Next up, we have this another term called resolver. Resolver. Okay, so this term was introduced in last video but not discussed. It was kept as abstraction. We'll be covering it now. So resolver is something that helps achieving resolution, right? That's pretty apparent. Now what happens is that DNS follows client server model. Okay, so DNS follows client server model. Okay, so what happens is whenever we have this host, and this host is in need of mapping, be it address to name or name to address, but this host needs to perform some mapping. It needs some mapping, right? So what this host does is it calls a DNS client. DNS client. Okay, so this DNS client is a resolver. Okay, so this DNS client is our resolver. Okay, so now what resolver does is it cannot solve the query itself. It cannot just map from address to name or name to address. So it will access closest DNS server. DNS server and sends the query. Sends the query. Okay, so what has happened? There was a host who needed mapping. Okay, so this host called DNS client. Now our DNS client is our resolver, right? Now resolver send this query to the nearest DNS server. Okay, so two cases can happen now. Either this DNS server has the authority. It's the authoritative. Okay, so this DNS server has the authority to perform this mapping. Okay, so this means either this DNS server has info, or this does not have info. Okay, two cases can happen. If it does have the info, then it will simply respond, right? It will perform the mapping and return it, right? So if it has information, if however this is not authoritative, right? It does not have the authority to provide us with the mapping, then two cases can happen. First one says that DNS server will be like that it is my responsibility, even though I do not have the information, I cannot perform the mapping myself. But what I can do is I can ask other servers. Okay. In other words, leave it to me. It's my responsibility. I'll ask other servers and I'll solve this query and I'll return the result to you. Okay, something like that. Other case can be that okay, I do not have the information and it isn't my responsibility, so I cannot help you any further, except I can give you one suggestion. Okay, I can give you one recommendation as to who you should approach after me, right? I do not have info, but this server might have the info. Okay, so this suggests other server that probably would have the information. Okay, so this is how resolution takes place, right? Now resolution is of two types: name to address or address to name, right? Okay, so name to address is simple. Okay, we like the process as I told you, that process is followed and we get the resolution that way. In address to name, there's one additional step. Okay, so what happens is that resolver gets the IP address. Okay, so IP address would be something like 132.24.44.121. Let's assume that this is the IP address. Okay, so this being the net ID, right? This being the net ID, right? So now this IP address needs to be converted into name. Okay, so if you guys can remember, net ID was supposed to be higher as compared to host ID, right? Host ID was supposed to be here, then above that was subnet ID, above that was supposed to be net ID. Okay, so this is how hierarchy should happen, right? And you guys also know that the naming convention goes from bottom to top. So it's node to root, right? So if it's 132 here, 24 here, 44 here, let's do. So it should go like this. Naming convention should go from bottom to up, right? So for that, what resolver would do is resolver would reverse the IP. So new IP would be 121.44.24.132. Okay. Next up, this resolver, what it do is append two labels. Append two labels. Okay. So these two labels are appended because above these network ID nodes, we have two first level and second level nodes. Okay, so second level node is our in ADDR, right? And first level node was ARPA due to historical significance. If you guys can remember the last video. Okay, so we will just simply append these two labels. Okay, so our new string would be something like 121.44.24.132 dot in ADDR dot ARPA dot for root, right? So this will be our new string, right? Now this will be sent to DNS server for conversion. Okay, so this additional step is added when we are mapping our address to name. Okay, now this is covered as well. Okay, so resolution is of two types. Resolution is of two types. First is recursive. Second is iterative. Okay, so we'll be discussing them both one by one. All right, guys. So first up in the discussion, we have recursive resolution. We have recursive resolution. Okay, so in recursive resolution, our client asks server for recursive answer. For recursive answer. What we mean by this is that client expects result from our server regardless of authority. Okay, so either our server can be authoritative, that is, it has the authority to provide the mapping, or it is non-authoritative, that is, it does not have the authority to perform this mapping, right? So there can be two cases, and our client expects the answer in both of these cases. Okay, so client says that you do not have the authority to provide this mapping. I do not care. I need the answer from you only. Okay, so this is something that happens in recursive resolution. Now there can be two cases, right? So first is our best case scenario, our hopeful scenario in which client gave some query to our server, and luckily the server turned out to be the authoritative one. Server turned out to be authoritative one. If that is the case, then server will do what? Server would simply check its database, right? And when it perform the mapping, it would simply return the result back to our client, right? These two things would happen. So server would return the result to our client. Okay. Now second scenario, not the hopeful one. So in this, client sent a query to our server, and server was not the authoritative one. Okay, so this does not have the authority to perform this mapping. So this server, since it needs to return the answer to client regardless, this server sends the same query to some other server. Okay, so this was server one. This sends the query to our next server. Okay, again with next server, there are two options that can happen. First of all, the server is the authoritative one, so it will send the response back. And if it isn't the authoritative one, it will simply perform the same thing as the last server did and send this query to some other server. Okay, so let's assume this server number 3 is the authoritative one. So this server found the mapping. The server performed the mapping. Now the result. Now this result is sent back to the server that send the query to this. Okay, so server number 2 send the query to our server number 3, right? So we'll send the result back to here, and this result would keep on traveling until we will reach the client that was requesting this result. From server 2 it will go to server 1, and from server 1 it will go to client. This is the client that was requesting this query. Okay, so the result reached the client. Okay, so this is our recursive resolution. So if I can show you with one example, I believe things would be more clear. So this is our example, right? We have this query, micro.com. Okay, so this is our client. Okay, now client is making this query or making this request to some server. That server is fhda.edu. Okay, now this server does not have the authority to perform this mapping. Okay, for this request, it cannot perform the mapping. So what it does is it suggests some others, it sends the request to some other server, right? So it sent the request to server number 2. Okay, this server is edu. Generally, the servers send for next request to their parents. Okay, so normally what happens is that whenever servers do not have the authority, so they send the request that they couldn't solve to their parents. Okay, usually, not in every case, but usually it happens. Okay, so fhd.edu would send this request to edu, right? Now edu does not have the answer either. Okay, so yeah, edu does not have the answer either. So edu will send this query to its parent, that is root server. Okay, so root server does not have the authority either, so it will send to com. Com does not have the authority either, so it will send to micro.com. Now micro.com is something, is a server which has the authority. It is the authoritative server, right? So micro.com performed the mapping, got the IP address, send this IP address back to com, right? The server that sent the query to micro.com. Okay, so com now response is here, right? Now response from here is sent to root. From root, response is sent to edu. From edu, response is sent to fhd.edu. And at the end, this response from fhd.edu goes to client, right? So this is how our recursive resolution would work in this case, right? Next up, we'll be discussing iterative resolution. Okay, so iterative resolution. We're covering iterative resolution, right? So unlike recursive resolution, iterative resolution does not require a recursive answer. Does not require a recursive answer. Instead, we can make iterative queries. Iterative queries. Okay, so we can make multiple queries. All right. So let's see how it happens, and that will make things more clear. So suppose we have a client. Now this client sends some query to our server number 1. This is our first server, right? Server number 1. Now two things can happen. Either the server is authoritative. Okay, so if the server is authoritative, it can perform the mapping and it will return the answer to our client. Okay, so this is the first scenario. The other scenario would be that this is non-authoritative. Okay, it does not have the authority to provide us with the mapping. Okay, so what the server would do next is it will say that I do not have the result and I'm not responsible for it anymore. However, I can provide you one suggestion. Okay, so the server provides us a suggestion for the next server that we can check, right? So it gives us some suggestion. Let's say the suggestion was server number 2. Okay, so client receives our suggestion and client makes the query to this server as well. Okay, so client makes the query to this server as well. Now this server, same situation would occur. It can have two possibilities. First of all, it has the authority to provide us with the mapping. If it does, it will simply return the result. It will simply return the result to our client. If it does not have the authority, then it will say that I do not have this mapping for you. However, I can give you one suggestion. You might want to try this, right? So client would again take the suggestion and make the query to our next server, and so on until basically we get a server that is authoritative and that can provide us the result. Okay, so this will keep on going. All right. So if you guys can notice, in this scenario, we are making multiple queries. Okay, so client is making multiple queries. The client is making multiple queries. However, if we see the case of recursion, client used to make only one query. This is our client. It made only one query to server. Behind the scene, no matter how many servers were used, client there was only one server concerned because it was communicating with only one server. So client asked the server the request and the result was provided to it. Okay, so this was what happened in recursion. But in iterative, multiple queries are happening, right? Now these suggestions are usually the parent node. Okay, they're usually the parent server. Okay, so if I can show you guys one example, I hope things would be more clear. So again, the request is micro.com. So client send this request first to fsj.edu. So it did not have the answer, right? So it said, I do not have the authority to provide you with the mapping. However, there's suggestion edu. Okay, so next up, client made the query to edu. Edu didn't have the answer either, so it returned that I do not have the answer. However, I have a suggestion for you, that is root server. Next up, client made the query to root server. Root server didn't have the answer either. It said, I don't have the answer. However, I have a suggestion, that is com. Next up, client performed the query on com. Com didn't have the answer either. It will return it back, right? Now, the next suggestion was micro.com. So client made the query to this, and this turned out to be the authoritative one, right? This turned out to be the authoritative server, right? So authoritative server, it was capable of providing us with the mapping. So it basically performed the mapping and then returned the result back to client. Okay, so how many calls are made by client? 1, 2, 3, 4, 5. So 5 calls were made by client. 5 times query was sent, and each query was done iteratively. That is our client who was responsible for making these queries, not our servers. Okay, so this is what happens in iterative resolution. Next up, we have a concept of caching. Okay, so let's understand the concept of caching, right? Caching. Okay, so first of all, we need to understand why was caching introduced, like what is the need of caching. Okay, so let's take a scenario. We have a client, and this client needs some mapping, right? So it sends the query queue to our server S1. Now S1 is not an authoritative server, so S1 will send our query to S2, right? S2 didn't turn out to be authoritative either, right? So S2 will send this query further to S3. Now S3 is our authoritative server. So what S3 would do is it will perform the mapping. Now this mapping would be sent to S2, right? S2 will send this mapping to S1. S1 will send this mapping to client. Okay, this would happen, right? Now let's say the same query happens again. Okay, so the same query happens again. We perform the query queue, right? S1 will not have the result again, so we'll have to send it to S2. S2 won't have the result again. It will again send it to S3. S3 would finally be the authoritative one, and the same procedure is repeated. The S3 would send the answer to S2, S2 to S1, S1 to client. Okay, so this is what's happening every time. So suppose this query occurs to server number S1 n times, right? So n times we will follow the same procedure, right? So too much time is being wasted in this because we are calculating the result multiple times and every time from scratch. Okay, so to avoid this, DNS suggested caching. By caching, what we have to do is that S3 turned out to be authoritative, right? So S3 generated this mapping, this response R, and send it to S2. Okay, now at this point, instead of just sending this response to S1, S2 needs to do one more thing, that is add this R to its cache. Add this R to its cache. Okay, so S2 will store it in its cache and then forward it to S1. Similarly, S1 will store it in cache and then forward it to client. Okay, so what happens with this is let's say next time we have the same query, right? Now we know that here we have response stored in caches, right? Response stored in caches. So next time same query is made by client. S1 will have this result stored in its cache, and instead of going all the way back, it will simply return the result from right here. Okay, so we are saving so much time because we are not performing same operations again and again, right? We have performed once and we've stored the result for that. Okay, so this is our caching. Now caching brings some problem as well. Okay, so what is the problem that happens due to caching? Okay, so let's say that a server is caching caching files for a long time. For a long time. Okay, so what would happen is that a server that didn't have the result on its own, but someone but asked some other server for result and then stored it in cache, has been storing this result for some time. It has been somewhere, right? So in this time, our cached result became outdated. Mapping became outdated, right? It has been updated in original authoritative server, but we still have the old result, right? So this becomes outdated. So if at this point client asks server S1, suppose it happened with S1, right? At S3, mapping was updated. Mapping was updated. If client asks S1 the same query queue, it has some response stored that was stored very long ago, right? So this response is outdated right now, but S1 will simply return this result regardless of this being outdated. Okay, so we are giving invalid result, right? So this is one of the problems that is introduced by caching. Now, how this problem is tackled? Whenever authoritative server authoritative server sends answer or result to a query, it sends some additional info as well. Additional info as well. Okay, so what that info is, that info contains TTL. TTL is time to live. Time to live. Okay, so this time to live is in seconds. Okay, so this field is in seconds, and this gives us the time interval for which our cached result of the query cache mapping is valid. Okay, so it says that, let's say TTL is 10 seconds, right? So server S3 sent TTL equals to 10 seconds, for example. So this means that for 10 seconds you can keep the result cached in your memories, but after that, after those 10 seconds are over, your cache result would be invalid. And next time the query occurs, you cannot give that cache result. Instead, I'll be answering the result. Okay, because I'm updating it after 10 seconds, something like that. Okay, so this is what TTL is. This is how we tackle the problem in caching. Okay, so this is it for caching, I believe. Anything left? I don't think so. Okay, one more thing. Okay, so if a server is sending a cache result, if a server is sending a cache result instead of original result, right, original mapping, so it will mark the response as unauthoritative. Unauthoritative to make sure that client knows that this result is not coming from some authoritative server, it is coming from some unauthoritative server that has stored this result in its cache. Okay, so this is how that is ensured. Okay, so all the topics are covered for this video. This is it from my end. See you in the next set of videos.